Pre-calculus, Lesson 2.1. Identify the vertex, axis of symmetry, and intercepts of a parabola using a graph, and identify the vertex, axis of symmetry, and intercepts of a parabola using its quadratic equation. The graph of a quadratic function is a U-shaped curve called a parabola, and given that graph, we'd like to observe several important characteristics. They are the vertex, axis of symmetry, and intercepts. Let's define each of these terms. One important feature of the graph is that it has an extreme point, called the vertex. If the parabola opens up, the vertex represents the lowest point on the graph, or the minimum value of the quadratic function. If the parabola opens down, the vertex represents the highest point on the graph, or the maximum value. In either case, the vertex is the turning point on the graph. In the figure on the left, we see that the vertex is the point 3, 1. Note that the vertex of a parabola is always a point on its graph. This particular vertex is the minimum value of the parabola. The graph of the parabola is symmetric along the vertical line drawn through the vertex. This line is called the axis of symmetry. When identifying the axis of symmetry, we note the vertical line x equals h, which in this case is x equals 3. The intercepts of any graph are the points at which the graph crosses the axes of the coordinate plane. The y-intercept is the point where the parabola crosses the y-axis. Because the graph of a quadratic is a function, there is only one y-intercept. The x-intercepts are the points where the parabola crosses the x-axis. It's possible for there to be 0, 1, or 2 x-intercepts of a parabola. If they exist, the x-intercepts represent the zeros, solutions, or roots of the quadratic function, the values of x at which y equals 0. The graphs below show when the graph of a quadratic function has 0, 1, or 2 x-intercepts. The graph on the left, we see the graph never touches the x-axis. In the middle, only the vertex touches the x-axis, and on the far right, we see that the graph crosses the x-axis twice. In this graph, we can see that the parabola crosses the y-axis at the point 0, 7, so the y-intercept of the graph is 0, 7. Notice that the graph does not touch or cross the x-axis, so there are no x-intercepts for this graph. Let's identify the vertex, axis of symmetry, and intercepts of the given graph. The vertex is 1, negative 1. The axis of symmetry is x equals 1. The y-intercept is the point 0, 0, and the two x-intercepts are the points 0, 0, and 2, 0. While having a graph to determine the vertex, axis of symmetry, and intercepts is very convenient, assuming they occur at integers, it is often the case we need to be able to discern them from the algebraic rule of a quadratic function. Luckily, we can find them from both forms of a quadratic function, as y equals a times quantity x minus h squared plus k, or as y equals ax squared plus bx plus c. Given the standard form, also known as the vertex form, y equals a times quantity x minus h squared plus k, we can easily read the vertex of the parabola. It's simply hk. Similarly, the axis of symmetry is easily read. It's x minus x equals h. The intercepts, on the other hand, take a bit more work, which we will discuss later. Let's identify the vertex and axis of symmetry of the given quadratic, y equals negative 3 times x plus 2 squared plus 4. The vertex is given by the point hk, and in this quadratic we have x minus h equals x plus 2, which implies that h must be equal to negative 2. The value k is read from the constant added or subtracted, which gives k equals 4. So the vertex is the point negative 2, 4, and the axis of symmetry is equal to x equals negative 2. Given the general form, y equals ax squared plus bx plus c, finding the vertex and its axis of symmetry is a little more work, but not much. The x value of the vertex h is defined to be h equals negative b divided by 2a, which is derived from the quadratic formula. This also gives us the axis of symmetry, x equals negative b over 2a. To find the y value of the vertex k, we must evaluate the quadratic function at the value h we just found. We evaluate k equals y of h. Let's look at an example. Identify the vertex and axis of symmetry of the given quadratic, y equals x squared plus 6x plus 5. We first find the value of h, yielding h equals negative b over 2a, which is going to be negative 6 over 2, which reduces to negative 3. Now we can produce k, yielding y of negative 3 is negative 3 squared plus 6 times negative 3 plus 5, yielding 9 minus 18 plus 5, which is negative 4. So the vertex is the point negative 3, negative 4, and the axis of symmetry is x equals negative 3. Let's now discuss how to find the intercepts of a quadratic function from its algebraic rule, y equals f of x. To find the y-intercept, we evaluate the function at 0. So the y-intercept is simply f of 0. The x-intercepts are the solutions to the equation f of x equals 0. It doesn't matter which form of the quadratic we're given. The process is the same for both. Let's identify the x and y-intercepts of the quadratic y equals x squared plus 6x plus 5. The y-intercept is found by evaluating the quadratic at 0. Y of 0 is 0 squared plus 6 times 0 plus 5, which is 5. So the y-intercept is 0, 5. The x-intercept is found by setting the quadratic to 0 and solving. So we set 0 equal to x squared plus 6x plus 5. And that factors as x plus 1 times x minus 5. Setting each factor equal to 0 and solving, we have x plus 1 is 0 and x plus 5 is 0, which yields x is negative 1 and x is negative 5. So the x-intercepts are negative 1, 0 and negative 5, 0.